6.1 Molecules and Temperature Scales. If we look inside matter, so for
7,
example, here is Earth. Here is Earth. What happens if we look more and more closely?
6, 5, 4,
If we look more and
3,
more closely,
2,
here
1.
we see a
We are back
person.
at our starting point. We slow up at 1 meter, 10 to the 0 power.
If we look inside a hand,
Now
what
we
do you think
reduce the
we're gonna
distance to our
see?
final destination by 90% every 10 seconds, each step much smaller than the one before.
So here's the skin.
At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand.
So we're looking more and more closely now.
In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within.
Inside our body,
Skin layers vanish in turn.
we see blood
An
vessels.
outer layer of cells, felty
Inside the
collagen,
blood vessels,
the
we
capillary
see
containing red blood cells and a roughly
cells.
lymphocyte.
So for example, the red ones here, these ones are red blood cells. These ones are white blood cells. Red blood cells transport oxygen that we breathe throughout the body. We'll learn more about that today. White blood cells help us fight off viruses and disease. Okay. What happens if we look
We enter the white
inside
cell.
a
Among
single
its vital
cell?
organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man.
When we look inside the nucleus, the center of the cell, we see
In the coiled coils of DNA.
this is DNA.
As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice in an
And when we
alphabet of
look
4
inside
letters
DNA is what tells
the
us
words of the
what
powerful
carries
genetic
genetic
message.
information.
At the atomic scale, the interplay of form
When we
and
look
motion
inside
becomes more
DNA,
visible.
we see something like this.
We focus on one commonplace group of 3 hydrogen atoms.
Here we go. What is this? Well, what we find here is you can consider a molecule. And inside this molecule, there are 1, 2, 3, 4 atoms. So inside everything, we can find molecules. We can find molecules inside people, inside tables, inside trees. It doesn't matter if it's living or not. Everything is made of molecules. And molecules are made of atoms. So today we will learn more about molecules and atoms. So we know that a bunch of atoms make up one molecule. What kind of molecules can we make? Well, water is very important. Water is H2O. If we have an oxygen here, a hydrogen, another hydrogen, that's water. Water looks like this. 1 oxygen and 2 hydrogen. Here's 1 hydrogen. Here's the other hydrogen. So 2 hydrogens and an oxygen. So that's why water is H2O. Okay. So water molecule consists of 2 hydrogen atoms, 1 oxygen atom. So 3 atoms here. 1, 2, 3. Okay. Now when we breathe, we take in oxygen. Well, that's what we're looking for when we breathe in. And some of what we breathe out is carbon dioxide. What is oxygen? Oxygen is just O2. 2 oxygens. That's oxygen. So there are 2 atoms here, 1 molecule. Okay. What about carbon dioxide? That's 1 carbon 2 oxygens. Carbon dioxide. So when we breathe in, we're looking for oxygen, O2. When we breathe out, we are mostly trying to get rid of carbon dioxide, CO2. So the oxygen has 2 atoms, CO2 has 3 atoms. Other molecules. Let's make some new ones. If we have 2 carbons and we surround this carbon with 3 hydrogen, this one with 2 hydrogen, an oxygen, and another hydrogen, we get something we encounter all the time. This is ethanol. What is ethanol? Ethanol is what we usually call alcohol. So the reason why people drink alcohol is because inside it contains ethanol. As we can see, ethanol is C2H6O. You can write it this way, C2H6O. You can also write it as C2H5OH. They're both correct. Yeah. And that's one ethanol molecule. That's what makes alcohol addictive. Okay. If you have a car, what comes out here contains carbon monoxide, which is CO. A carbon and an oxygen. 2 atoms. Very simple. If we get too much CO inside the body, we can get carbon monoxide poisoning, and that can cause us to suffocate and die. Carbon monoxide molecules bind to the red blood cells we saw earlier, makes it hard for us to transport oxygen throughout the body. Okay. Well, this is baking soda. We use it for cooking, we use it in our toothpaste, we use it to keep things smelling okay. That's sodium bicarbonate. The sodium is Na, that's one sodium molecule. Bicarbonate. Okay. How many atoms are there? 1, 2, 3, 4, 5, 6. 6 atoms. You can just count. Okay. What about glucose? When we're eating, we're mostly looking for a source of energy. There are many types of sugar. One type of sugar is glucose. Well, it's hard to count, like 1, 2, that's going to take a long time. However, we know glucose is C6H12O6. That means there are 6 carbon molecules, 12 hydrogen molecules. Sorry, I said the wrong thing. 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So one glucose molecule has 6 plus 12 plus 6, which is 24 atoms. Now, in this unit, we're going to study mostly molecules. But inside a molecule, we have atoms. And inside every atom, we have protons. And what kind of atom it is depends on how many protons there are. For example, oxygen has 8 protons and some electrons. Usually, the number of electrons and the number of protons is the same. We will learn a lot more about this when we get to the electricity unit. And there are some neutrons inside too. Okay. So this is a single oxygen atom. Note that this is not a molecule. This is what's inside a single atom. So what is inside an atom? We have protons, which have positive charge, neutrons, no charge, and electrons, negative charge. We will talk more about this when we learn about electricity. But in this unit, we'll focus a lot on molecules. So what is today's temperature? Let's go to Boston weather. Today's temperature is 35 degrees Fahrenheit. So in Fahrenheit, it is 35 degrees. I'm going to just copy this. 35 degrees. Okay. And in Celsius, it is 2 degrees Celsius. In other words, 2 degrees Celsius and 35 degrees Fahrenheit are the same. So when it's a cold day, it might be like today, it's like 32 degrees Fahrenheit, 0 degrees Celsius. In a hot day, it might be 85 Fahrenheit, 30 degrees Celsius. So 32 degrees Fahrenheit is cold, but 32 degrees Celsius, that's hot. We can convert between these two. Here's a formula. Fahrenheit is 1.8 times Celsius plus 32. That's a formula. For example, body temperature is about 38.6 degrees Celsius. What temperature is this in Fahrenheit? Here's a formula. We don't know Fahrenheit. Celsius is 38.6 plus 32. Okay. So that means that degrees Fahrenheit is 1.8 times 38.6. That's 69.48. So I'm going to say 69 degrees Celsius plus 32 degrees Celsius, plus 32. So we're getting, let's see, yeah, I apologize. Really, the body temperature is really 37 degrees Celsius and not 38.6. See, 37. So let's use 37 for our problem. 1.8 times 37 is 66.6, so let's say 67. So here we're getting, it's about 99 degrees. It's really 98.6 degrees Fahrenheit. We can also do 66.6, in which case we get 98.6. That's why we say body temperature is about 98.6 degrees Fahrenheit. One more. This time we have Fahrenheit and we want Celsius. Okay, so this time this is 42. We subtract 32 from each side. I get 10 equals 1.8 times C. Divide both sides by 1.8. So we do 10 divided by 1.8. That's 5.5, 5.6. So it is 5.6 degrees Celsius. Okay, that's it.